Howdy. It might be a good time to talk a bit about Halloween. So we are here on Britannica. And just have a quick read into Halloween. Contraction of All Hallows Eve, a holiday observed on October 31st. Yeah, it's funny, you can observe a holiday. The evening before All Saints or All Hallows Day. The celebration marks the day before the Western Christian feast of All Saints and initiates the season of All Hallow Tide, which lasts 3 days and concludes with All Souls Day in much of Europe and most of North America. Observance of Halloween is largely non-religious. Halloween had its origins in the festival of Samhain among the Celts or Celts of ancient Britain and Ireland. On the day corresponding to November 1st on contemporary calendars, the new year was believed to begin. The date was considered the beginning of the winter period, the date on which the herds were returned from pasture and land tenures were renewed. During the Samhain festival, the souls of those who had died were believed to return to visit their homes, and those who had died during the year were believed to journey to the other world. People set bonfires on hilltops for relighting their hearth fires for the winter, or hearth for the winter, to frighten away evil spirits, and they sometimes wear masks and other disguises to avoid being recognized by the ghosts thought to be present. It was those days that beings such as witches, hobgoblins, and fairies and demons became to be associated with the day. The period was also thought to be favorable for divination on matters such as marriage, health, and death. When the Romans conquered the Celts in the 1st century CE, they added their own festivals of Feralia, commemorating the passing of the dead, and of Pomona, the goddess of the harvest. You can check it out. I will put links below. Canada Day. All right. Yeah, we won't dive into that. Yes, Halloween. So let's have a quick look, because I have made my own thoughts about Halloween. I made some amount of research into the topic of Halloween. I know about Randall Carlson explaining Halloween with some meteorite showers or stuff like that. Mathematical and and yeah, there might be more to the story. Let's check out something. Plate tectonic issues, the influence of electricity in rock forming processes, and a coherent connection between science, mythology, and history of Finland, Part 3. Part 2 got stuck in the peer-reviewed process since it's considered to be too thought-provoking. Yeah, whatever that means. It doesn't seem to be wrong. So it's just too thought-provoking. What to do? I think I wrote it even down in the paper itself, that the paper is intended to provoke thoughts about this topic. Yeah, I cannot do anything more than that. Then just say it's meant to be thought-provoking, and somebody then is complaining about it being too thought-provoking. Yeah, maybe that's an achievement in itself already. I don't know. Maybe it's never gonna be published. Maybe it still gets published somewhere. I don't know. Let's see. Maybe I got to write it all over, but I don't want to in a way. So that's the part 3, which isn't really yet finished. It's still under construction. They say that a little knowledge is a dangerous thing, but it is not half so bad as a lot of ignorance. Terry Pratchett. Yeah, he knew much about witches. I recommend you to read Pratchett's book about Tiffany and these kind of things. They are very interesting. Yeah. Witches, Halloween, Terry Pratchett, and of course, peat, peatlands, wetlands, swamps, or however you want to call them. So there's a content abstract comparison of different theories about peat and other contradictions in science, creation and accreation of peat from a new perspective, peat's active role in the environment, and in the end of the last ice age. You probably haven't heard that before. 2. Cultural rituals and mythological stories revolving around peat, conclusions, references. Keywords: electromagnetism, sun cycles, geology, transmutation of elements, shockwaves, induced currents, earth as a capacitor, amorphous and crystalline silica, easy water, zeolithic water, alkalinity, acidity, hydrogen anion, daisy chains, mineral phases, craters, and this could be continued still. Let's put here still. Telluric currents. So you can see it's in the making. Now let's just dive a bit into the beginning of that abstract. Many of the modern sciences exist within the uniform materialistic notion that, except for the Big Bang, everything happened at a steady pace over millions of years. Every now and then an asteroid falls on Earth, sometimes with devastating consequences like the extinctions of the dinosaurs. Most often they just burn in the atmosphere without anyone noticing it. But otherwise, things happen generally very slowly. When reading or watching something about ancient people, it cannot be overheard how often it is expressed that not only the hominids or humans, but also the animals seem to always struggle to survive. Since the author realized this repetitive pattern once, he got sensitive on this topic. In the author's my opinion, this assumption is a totally empty phrase and seems to have only one purpose: lifting modern man even higher in the strange hierarchy of living beings. We have conquered nature, or science is settled, are expressions some seem to believe and take them as absolute truths without understanding their own lack of critical thinking. Yeah, these are my thoughts. Do your own research, please. I don't expect anyone to agree with me, but it's just that I came up with those kind of thoughts through my own research about these topics. Anyway, many things which are used to keep our modern society going are not very well understood. Often it is more known about how to use something than about its origins. Most people simply don't care. Many people are also not really aware of what they are saying in terms of everyday language. For example, many sayings used by the people. What does it actually mean? Where does it come from? Why is the sun reindeering? There is a big possibility that the animals and peoples of the ancient times were thriving in an exceptionally fertile environment where food, water, warmth and light was much more abundant than many could imagine. It might have been a totally different world, and stories about the old sun or the good sun only undermine these possibilities. On the other hand, we also have evidence that the past wasn't a forever stable time. Many things have changed over the years, and it is foolish to believe that nothing is going to change anymore. Many species went extinct, but also new ones formed. Every now and then, archaeologists find new evidence that ancient people were more advanced than previously assumed, which sometimes poses problems to their interpretations of certain patterns. Geology is also full of contradictions, assumptions and unprovable claims. which are often explained away by using extremely long timelines. Often they just don't seem to care too much about the contradictions, and they just move on with, oh, look, a bird, kind of attitude. Birds are dinosaurs, so they didn't go extinct. Peat is something most of us are familiar with, at least to some degree. It is found all over the globe and usually related to water. Despite the huge amount of literature about peat, bogs, fens, or wetlands in general, the origins and creations of it are not well understood, and it is classified as a geomorphological phenomena. In other words, they don't really know how it got created or where it came from. When talking about wetlands, we have still water, not flowing, as a key component which is usually stored in lakes and ponds. According to mainstream scientific theory, some of these water bodies are seen as meteor impact craters. Often they are seen as a result of plate tectonics, but also glaciers might have carved them out. The end of the last ice age seemed to have happened rather quickly in terms of melting. The author, me once again, still, thinks that peat might have played a crucial role in some of the melting processes due to its electromagnetic properties. Peat will be the main topic of this paper, but other topics will be discussed as well. Not only because they are interesting, but also to show how, at first glance, seemingly unrelated things are surprisingly similar with each other. Yeah, it's interdisciplinary. What to do? Where have we been? With each other. Earth provides an ever-changing environment for life in a cyclical manner. That's an important point. Cyclical manner. It and all the other planets with all their moons are contained within the Sun's magnetosphere. The Sun is nowadays not only geographically the center of our solar system, but also energy-wise. This implies that it might have been different in the past. All the planets are constantly connected to the Sun by interplanetary Birkeland currents. The Sun, and therefore all the planets of our solar system, are constantly connected to the center of our galaxy with intergalactic Birkeland currents. Birkeland currents are strings of electricity which have many recognizable patterns, of which the most important to understand are the magnetics, because they are the easiest to see with bare eyes. Every electric current has a magnetic field, sphere, and every magnet has electric currents flowing around and through it, the magnetic flux. But we won't now make a whole read-through, we just scroll through that comparison of different theories about peat and other contradictions in science. There might be some pictures even here somewhere. Yeah, I list some people for. The author is aware of this not being the correct way to present names and works in a scientific paper, but this way I make sure these names are noticed by the reader. Christian Birkeland, Hannes Alfvén, Nikola Tesla, Immanuel Velikovsky, Ralph Jürgens, Halton Arp, Anthony Peratt, Michael Steinbacher, David Talbot, Walt Thornhill, C.J. Ransom, Victor Schauberger, and there should be, of course, many more. People like Andrew Hall. But anyway, we are talking still about the Halloween. CO2, a simple diagram which shows how the CO2 content of Earth's atmosphere declined over time, and it also could give some people headaches. It just went down and down and down and down and up. It just went a little bit up. So now we go to the last part, which is unfinished still. We are talking about quartzite problems and stuff like that. In the paper we have Whoa, what were they called? Gravity worms? These are gravity worms? No, they are not called gravity worms here, but they are called gravity worms in another place. And I think that's the gravity worm, the electromagnetic wave. We have fulgurites deep in the ground. Peat's active role in the environment and in the end of the last ice age. Of impurities. Alright, let's go with that. We have to still scroll down. There are some pictures made or put here. Here we have a swamp. Peatland near Varpuvaara, Finland. And it has this pattern. You can find them, there are thousands of them. Just go to Google Earth. Here are the coordinates. Push pause if you want and you can go to check it out for yourself. We also have Billy Elverton's, however you spell that name, Billy Elverton's experiments. And they are in a way creating similar patterns as to peatlands. We are talking about craters. Laboratory, 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 real, real. And as you can see, this picture here in the middle is between this and this crater. So this background is one picture. So we have this crater beside this in the real world, as we have these laboratory craters side by side. Just for comparison. Mining, gas or oil plants are on white ground. But anyway, yeah, I think we are finally going to the part 5. Cultural rituals and mythological stories revolving around peat. The modern Western society has certain annual festivals. Some are tied to Christian beliefs, but also are some of pagan origin. Whatever the case may be, they all share one thing. They are heavily monetized. Their original meaning or purpose got lost a long time ago. The story got reinvented and changed to fit certain religious paradigms. This also functions as a wiping out of ancient knowledge for common people. A further tool to achieve a similar result is education. Uniformitarianism has its origins in England. It is the cradle of settled science on which mainstream science is based upon. Yeah. Remember, we were reading Britannica in the beginning. But anyway, back to the paper. It is the cradle of settled science on which mainstream science is based upon. Oxfordian science is very tightly connected to Christian beliefs. The origin of peer review process also originates in England. It was invented to make sure the results of whatever scientific discovery don't give any possibility to question Christianity, the king, queen, or whatever artificial authority. Still, as kids, we are awaiting Christmas time. In spring, we celebrate Easter and occasionally other days off school because the church wanted to. The author hasn't been raised in any specific religious frame, and only because of certain rules of authorities, time in churches was spent. It always felt strange to participate in these rituals because they didn't seem to be from this world. Stories got told, rules explained, and ritualistic procedures were performed. Over time, the author learned that there are also other religions. Later it turned out that they fight with each other basically since their existence, despite promoting that peace is the ultimate thing to achieve. For the author, the amount of contradictions, outer-worldly stories, and the rigorous defense system of each religion towards the others always posed a very big problem. It simply didn't make any sense. Discovering the electric universe with all the people and their works which were leading up to the point of where it is now opened up a whole new way of looking at things. It is such a unifying theory that it seems too much for too many. There seems to be a deep-rooted fear to let go of old beliefs and embrace new ones. Almost no amount of contradictions is enough to let go. Rather, believe in something that got taught in school as an absolute truth than in something which is understood and thought about. Let's take Halloween! Yeah, now we got there. Let's take Halloween as an example of an ancient cult embraced by capitalism and maybe even kept alive by it. Many people don't really know what Halloween is about. They know that at the time of the year there are scary faces carved into pumpkins and that there should be a candle burning in the pumpkin in order to make it visible in the dark. The only time of the year when you can see witches. Yeah, I'm a witch. It seems like. After my research. Anyway, so I'm not a scientist. But why? A scary pumpkin glowing in the dark? Witches? Most people never took the time to actually think about things like this. Too many don't even want to know and they will have an excuse for it, which, after all, could be quite likely rooted in fear. I maybe have to change the sentence. They lack the ability to be honest to themselves and admit that they were wrong, or the new knowledge would partially destroy their worldview. It is important to understand that the old knowledge doesn't go away. It will remain and it can be processed in new, different ways. Once you start to see it, you can't unsee it anymore because the forms, patterns, visual or literal, are omnipresent. As explained in part 2, light phenomena in nature might have been much more common in ancient days, and very often they seem to be related to plasma. Yeah, part 2 got stuck somewhere. Maybe I have to present it here once. 50% of swamps in Finland are drained. This number could be much bigger in other countries. Considering water as a universal conductor and therefore as something very important for the energy to flow, we will have a chance to try to understand the importance of wetlands for the electrical environment. They are batteries. They provide energy for processes which include earth and heaven. Yeah, the battery thing was explained earlier in the paper. But we are talking about Halloween. Maybe I make later a video about the battery thing. Maybe not. I don't know. Let's see. The ground might look stable. No. They are batteries. They provide energy for processes which include earth and heaven. Taking the water away will break the battery. Wetlands, peatlands, bogs and such are considered mythical places, often misty, and going there can be dangerous. The ground might look stable, but it isn't. And the possibility of drowning in an unknown wetland is a real danger. In the past, several hundred years ago or so, wetlands were probably much more abundant than they are nowadays. Remember, I have been talking about the abandoned castles all over in Europe and many other places? They had to be abandoned because the water ran out, the well on which it was built on dried out. You cannot live in a castle if you don't have water. Anyway, there was more water back there. Many things point to this. This could mean that the overall charge in the environment was much bigger than it is today. Huge areas of wetlands were doing their thing. They created such an environment of charge that they had their own microclimate. The net negative charge, possibly due to quartz acidity, created water vapor in the area. Maybe the hydrogen anion has to do something with that too, but anyway. The huge amount of water they bore we probably also understand that the energy confined and produced by such areas was far bigger than it is nowadays. This is a very important point to recognize because the author thinks that the jack-o'-lantern, the pumpkin, is a representation of plasma phenomena. They occurred in peatlands probably much more often than they do nowadays. It might be something similar to St. Elmo's fire, which was described by sailors. St. Elmo's fire, also called witch fire or witch's fire, is a weather phenomenon in which luminous plasma is created by a corona discharge from a rod-like object such as a mast, spire, chimney or animal horn in an atmospheric electric field. It has also observed on the leading edges of airplanes, as in the case of British Airways Flight 009 by US Air Force pilots. The intensity of the effect, a blue or violet glow around the object, often accompanied by a hissing or a buzzing sound, is proportional to the strength of the electric field and therefore noticeable primarily during thunderstorms or volcanic eruptions. St. Elmo's fire is a reproducible and demonstrable form of plasma. The electric field around the affected object causes ionization of the air molecules, producing a faint glow easily visible in low light conditions. So, this is what I'm trying to talk about. Illustration of St. Elmo's fire on a ship at sea. Here are the you can see them. Why do charges accumulate at the surface and at the tip of a needle? If we place a positive charge on a conductor, why will the charge distribute themselves only on the surface? And why is the distribution uneven, like for the second imaging describing the needle? This is not a duplicate. I know that the E field from a conductor should, for some reason, be perpendicular to the surface. But that does not explain why there are so many positive charges at the needle's tip for me, since intuitively I think there is less surface at the tip and hence there should be less charge compared to the rest of the body. This was a question of someone. The charges distribute on the surface because this is the only place where a stable equilibrium is possible. If you had a charge inside the conductor, it would get pushed by the other charges until it cannot be pushed anymore, which happens when it meets the surface of the material. But anyway, look at the picture, it tells more than 1,000 words. St. Elmo's fire. Back to the paper. St. Elmo's fire. Their appearance must have been a rather frightening experience for the onlookers, especially when the lights emitted some sound. It is not known to the author, me, if there has been any relation to solar activity, but it would only make sense. Remember this, we will go back to that. GICs, geomagnetically induced currents, traveling through the crust. The stuff where we are walking on, the ground, of which peatlands are a part of, could have charge the environment even more than usual. At a certain height above the ground at a certain height above the ground, an atmospheric charge differential. Yes, now I have to just start again the whole sentence. Now it makes sense. At certain height above the ground, an atmospheric charge differential, geological features including metals or other conductive materials, and gas emissions from the moor created a brief accumulation of charge in the air, so much so that it started to glow. We can call them plasmoids. There might be a very wide variety of plasmoids. Some of them probably burn cool. Plasma has different stages, and we might look at a phenomenon which goes into the realm of glow mode. The position of those ominous lights in peatlands might in certain cases be almost the same. I mean that they are in the same places appearing again and again. The author thinks that this has something to do with the geological setting, like the bedrock itself, which, as earlier explained, seems to form daisy chains reminiscent patterns, like you have seen the patterns in the peat I showed you earlier. Other factors like temperature differences, amount of sunlight, moisture content of the atmosphere and the ground, etc. will have effects on the occurrence of lights. They might move around, hover up and down and change in size, shape and color too. Something like a discharge upwards as described in part 2, the streamers from volcanic plasma phenomena. Yes, streamers could be expected too, when the plasma ball bursts. We also need to recognize that, depending on the atmospheric condition, hence gas mixture, it might not need very much of a current in order to get something ignited. In this case, we are looking more at something burning instead of glowing. The paper minimum values of voltage, current or power for ignition of fire states, quote, no electrical ignition will occur under conditions of zero voltage, current, power or energy. Conversely, ignitions can occur when substantial amounts of voltage, current, power or energy are available. This leads one to consider that there may be some lower limits for ignition to be possible. This is consistent with the general observation that for ignition to occur of substances which are not self-heating or exothermically reacting, some finite amount of external energy must be provided. There is no reason why the environment, now I am talking again, why the environment, which needs to be understood on all scales and as a whole, like Earth, Sun, Galaxy and beyond, and not just locally, Earth or even just a specific area, couldn't provide unprecedented amounts of energy. Considering this thought, we should expect these kinds of phenomena to ignite fires. But since they were presumably happening in wetlands, we could imagine that they didn't spread very far. Maybe just one burning bush. Yeah, burning bushes. Nowadays, as we have so many dried out peatlands, wetlands, or the water level is generally lower than back in the days, the possibility of underground fires ignited by induced currents, GICs, which are very hard to extinguish, is much higher. Also, common lightning strikes can ignite places which were formerly wetlands much easier. Considering also energy peaks in telluric currents, which could be understood as underground lightning, the possibility of fires breaking out many meters below the surface shouldn't come as a surprise. It is, after all, a similar mechanism which could have melted the ice and snow at the end of the last ice age. Induced energy travels underground and heats up the ground. Taking into account that in many places there was a lot of water, rarely things ignited, nor could the fire spread very far. Nonetheless, We have a charged environment and strongly fluctuating telluric currents which easily can make stuff light up in different ways. Yeah, as I have proven with my microwave experience, induced electromagnetic radiation into some pebbles can make them melt, can make them burn. They have plasma discharges. They glow. Already the fact that there are several ways to have something glowing in the dark is a rather strong argument for an electrical explanation of the jack-o'-lantern phenomena. So, then we have 1,000 words of the Kalevala I'm working on. I want to highlight this because a few days ago Ben Davidson provided me with a very interesting clue. Listen up, Randall Carson. Anyway, it is not known to the author, me, if there has been any relation to solar activity, but it would make only sense. But it would only make sense. Yeah, whatever, you get the idea. There must be a reason for why Halloween is when it is at the end of October, beginning of November. And in order to undermine what I mean about the plasma stuff and induced currents and stuff like that, that this could be all related back to the sun, which doesn't answer all the questions. First of all, why does the sun do what it does at that time? But anyway, I think that's a rather long video, so I will show you quickly a part of a recent Suspicious Observers video. 3 days old. Solar flare records. Now let's just have a look at this and think about geomagnetically induced currents which could have possibly make things light up, especially in swamps, peatlands, moors and stuff like that, because their electrical properties and stuff. It's acidic water and we have limestone and all these kind of things. There's a lot of charge in those places. That's why they are mystical. These are places of real power, not just imagined. So, let's have a listen to this.
The top story today is a brand new solar flare record. They recalibrated the X-ray flare ratings based on saturation of the sensors, and it has now given us the list of the largest 38 solar flares of the satellite era. It upgraded the 2017 flares over X10 and tells us we are very much overdue for a major flare event. What's most interesting is that while it is common solar physics knowledge that flares should be random and evenly distributed across the Earth year, that's not at all what we see. If we take the last week of October and the first week of November, 8 of the top 38 events occurred during that time frame. Those 2 weeks only represent 3.8% of the year, and so we'd expect that period to contain about the same amount of the large flaring activity, but instead, those 8 flares on the list in that 2-week window account for 21%, more than 5 times what we would expect. We have been saying that the end of October and beginning of November could deliver more flaring activity, and if that ends up being the case again this year, it may merit further investigation of the disproportional flare distribution. Lastly, folks.
All right. Last week of October, first week of November, 21% of the flares. So this paper has to be worked on because it seems that I'm up to something with this Halloween thing, geomagnetically induced currents and stuff like that. I'm working now since more than 2 years on this paper. There's so much stuff popping up all the time. And it wasn't really about Halloween, it was more about Peat. But now it seems, or it could be, that Halloween is one of the key factors of my theory not being too crazy at all. It's just new, it's novel. So, it seems that solar activity has quite well something to do with Halloween. St. Elmo's fire, jack-o'-lantern, the pumpkin. Yeah. GICs, ignited stuff. But anyway, I think I leave it here. My theory about Halloween. And yeah. If you're not too busy and interested in the topic, tell me what you think. If you know something I don't know yet, tell me. I'm eager to learn because I really would like to know. Not only about Halloween. But anyway, thanks.